which has been presented before at various TCPM meetings, and this draft's now in working group last call, so hopefully you've read it. If you haven't, please do read it. There were a few changes in drafts over the time with the latest changes were removing the ECN parts, which I probably have to justify. Hopefully, if you've got comments, please come to me, please ask now. We removed the text on ECN largely because we thought this was a different issue and should be dealt with as ECN evolves, as we decide finally how to pin down ECN. Rather than include words about ECN markings, we do not have those in the latest version of the draft. We talk about standard reactions. That includes a standard reaction to ECN, but it allows that if ECN changes or is updated by accurate ECN, for instance, the draft will still be okay. We removed the update line from RFC 5681, which would become a down ref, largely because this is going as experimental and we can't update a standards track document. We have editorial changes, and we did no changes to the method across all these revisions. The method's been constant over all of them. Next slide. The reason this document is being put as experimental, I should just reaffirm, is because we believe as a working group that the document will require experience in the field with deployment and testing to become a standards track document and become a PS. So it's going forward as experimental. We believe there's no open issues, and we would like to receive comments in the working group last call, or take them now.
Yeah, I can just back this. So as far as I recall, there have been no comment at all in the working group last call, so that's a good sign. So if you have any thoughts or comments, then speak up now. Otherwise, we will move it forward.
You could also send a comment saying you've read it, which would be nice at least to know people have read it, to give a bit more confidence.
Yeah, maybe we can have a show of...
Wolfgang Beck, Deutsche Telekom. In general, I think this document should give some implementation advice. In the last few weeks, I had to struggle with 2 TCP implementations of major vendors which were flawed. One didn't handle reordered packets, the other didn't take into account that TCP directions have traffic in both directions. And it was an old FreeBSD implementation which did something similar as you proposed in this draft. This in-flight limitation they had until 4 years ago or something. They did try to measure the bandwidth delay product, but they didn't take into account that a packet containing an acknowledge can contain data as well. So they underestimated the bandwidth delay product and throttled the congestion window too much. So just as a general observation.
Okay, if you can send some comments to me via email, that would be helpful.
Yeah, so these kind of things it's good to discuss them on the TCPM mailing list. So there's a lot of expertise on exactly such bugs in certain TCP stacks. So TCPM is a good place to raise such issues.
If you're at all interested in these things, we are still working on supporting Linux, and we still have BSD code that can be made to do new CWV. So if you're using that, or if you're interested in using that, please tell us, because we'd like to keep the momentum going on this.
Okay, so let me just one show of hands. So how many people have read one of the most recent versions of this document? So that's of the order of 5, 7, I would say. Okay, thanks.
And the number was 7?
7.
Okay. Thank you.
6 or 7, something like this.
All right, 6 or 7.
Okay, then next is Anna.
Okay, so I'm Anna Brunström, and I'm presenting the TCP and SCTP RTO restart. I think you all know the algorithm by now. So when an ACK comes in, you get the added delay to the timer, and RTO restart removes this delay in cases when fast retransmit cannot be used. Next slide. So we have also not had any updates to the algorithm. So what's happened in the new version of the draft is that we have clarified some of the text based on feedback from the mailing list. So we introduced a new variable, previously unsent, that captured this. RTO restart uses the number of outstanding packets and the number of packets in the queue that have not been sent to determine if you should activate the algorithm or not. So we have clarified this point and also added some more text in terms of how you can implement tracking the outstanding and the previously unsent segments. So both how you can use it for packet-based and byte-based stacks, and how to track the previously unsent segment. And we have also clarified that this tracking is not critical to the algorithm, because the introduction of tracking this number of packets that have not been sent yet was introduced to fix a corner case that was detected by Alex. So you could just run the old algorithm if you feel that the implementation gets too complex for you. Next slide. We also added some more text in relation to the risk of spurious retransmissions, and that this can also have an effect on the network, and also clarified in terms of what experimentation is needed, that it will be useful to look into environments with highly variable RTTs. Also clarified a bit in the text that it's an experimental algorithm, so the recommendations for turning on RTO restart is in relation to experimentation. Next slide. A little bit of text updates to the related work section in the relation between RTO restart and Talos probe. Some clarifications to the security section, that the security considerations from RFC 6298 also apply to this document, so there are no additional security issues as we know of at this point, but issues in 6298 apply, and then some other minor updates to the wording. So the algorithm is the same, it has not changed. The only thing is that we introduced this reference to the variable to clarify that part. And the implementation is also been the same, just updating it to the new, as the new versions of Linux are coming, so that it's available in the latest version. And you can get access to the code if you want to try it and play with it. Yep. Questions?
Michael Tixon. This applies to TCP and SCTP, at least in the title. So, and you said you envision it to be that I can enable, disable it system-wide. Do you envision that I want to do it per connection, per socket? Because for SCTP, for documents describing SCTP extensions, we have a socket API considerations section where if you envision that it's a socket option, for SCTP at least, have some text describing the socket option. Or do you say, no socket option, only system-wide on and off?
I think that for the experimentation you can just turn it on system-wide. I mean, if this is the way it's working at the, well, we haven't played with it in SCTP, but this is the way it works at the moment. I think we have this
being deployed. Just put it out on all boxes and switch it on, and don't give the application a chance to disable it or enable it on purpose, or.
Well, you can still. I mean, you can still turn it on or off on your system, right? But you want
not as an application writer. If I'm writing an application and I want this feature, I don't want this feature. I have no control, because I can't switch it on system-wide because I want it, or turn it off system-wide because I don't want it. So is there a reason I want to use this or not on an application choice, or is this always better? I mean, like Nagel, we can control.
Right.
There's a default on, but applications can say, no, I don't want it. So that's why I'm.
Yeah, I think for Nagel there's a more clear distinction on whether this is beneficial or not, right?
Yes.
I mean, here you may have, in some cases, it will be trade-offs between different aspects, but those will be difficult to know at an application as well, because it will depend on the timings in the networks and things like that. So I think it's a more difficult choice for an application than naval, right?
Sure. I'm just asking if. So my only point is, if you envision that this might be something an application might want to control, put in a section for SCTP, at least for SCTP, and saying this is the socket option, this is the name, this is the structure. I can help if you want with the text.
Would you like to control
if you want
it
this
from
kind of
the-
stuff, I can send you the text I would put in for this. However, it's up to you to say we want to expose this to the API. But in the other SCP documents where we have something user controllable, we add the socket API section to that. So that it's clear for someone implementing it for SCTP and exposing it, this is the way to do it, and you can write a portable application. So let me know if you want text.
So generally, I think the difference between TCP and SCTP is in TCP we typically don't do this API stuff, and that's why it's also new to me, to be honest. But I guess we have to. But it's a valid comment. If for SCTP we need it, we have to look into this. I agree.
I mean, it's no problem to add it. I mean, if we want.
I mean, the separate question, but let's first go with the mic.
We can talk about it a bit more offline as well.
Matthew Welser, the co-author. I will say something people have heard me say yesterday. If there is no application-specific need to turn it on or off, I don't think there should be an option for an application. This is an optimization that is dependent on network environment conditions, and I think the only basis for deciding to turn this on or off would be network environment conditions and nothing that is application-specific, so I don't think an application should choose that.
Yeah, there can be some connection also to, I mean, the effect is dependent on both the network characteristics and the application send pattern, right? But you clearly don't have the full knowledge at the application because you don't know about the network part. So that's why I was a bit unclear in my answer to Michael as well.
Mia Kulevind. It's true that we usually don't do this for TCP, but maybe we should start right now at least discussing, just writing a small paragraph, say if it's useful to expose this to the application or not. Just writing down the thoughts on this so other people can make a better decision if they want to implement such an option or not.
I don't know whether it needs to go into the socket API or not, but I can say that from a signaling application perspective, this is probably something that we would want to configure. We may not, and there's a lot of things that are today in socket options, and we configure them either on the socket options or while we have a different interface implemented as well. We probably would not want to configure the RTO restart on a per association basis. I mean, but I think so. An application would probably not need to tune this on a per application basis, but it could very well be that some nodes want to have this tuned on and others would not. Exactly depending on which environment that they happen to be running in. So I think that that we, from our perspective, would implement this configurable, and it could be then implemented as configurable in the socket API.
Yeah, I mean, clearly I think it should be configurable on a system basis, at least, right? But yes, I wasn't...
System basis, for me, I mean, system basis could be like when you compile the code. And what I'm saying is that we would implement a configuration option that would be runtime. And we, most of the options that we do this with, we also have them as socket options.
So, should I interpret that you would like to have the socket option?
I will not promise that we would use it, because we also have a different API, but yes, I think it makes sense. I think it's, I think that the runtime configuration need is there, and we would use it. And we would implement it if it wasn't in the socket API, we would implement it as a proprietary option.
So, Gary Fairhurst, when we do this stuff in TSVWG, we just normally create an informational section and try and make the implementers agree on what we're going to call it, so that actual name reflects what's actually in the implementation. So If we go this way, I suggest you talk to the stack people and pick a name that would probably work, and then just document it.
By the way, now I'm speaking HTTP. We do the same for TCP. We will, when we enable this feature for TCP, implement a proprietary socket option in our POSIX API that controls this.
Okay, that exactly comes to one question that I have. So I'm hearing here that for SCTP there seems to be some interest in having the socket option. So now I'm wondering about the TCP case, because as I said, out of my head, we have not specified socket options in TCPM. Or we may have some, but they are not for the RTO at least. So it's something we've not done so far. So is there any thought here on the community, first of all, for the TCP case, whether the document should specify an abstract API for TCP? As I know from the multipass TCP working group, there has been pushback on specifying the socket option specifically. It was always the demand for an abstract API, but we could do this. Any thoughts here?
So on SCTP, we don't do an abstract API. We do a very concrete one. We give
Yeah,
you
I
names
understand.
defined. And when we do this here, we give you a name called SCTP, I don't know what. But, I mean, if someone reads this and thinks about how do I name this for TCP, I guess replacing SCTP with TCP is the way to go. So I guess if we lay it out for SCTP, it's easily guessable for someone doing this in TCP using an appropriate name. And they don't have the complex stuff with the association, so we might have a special structure that they will use an int. So I guess if we specify for SCTP in a concrete way, you can guess what it is for TCP.
Yeah, sure.
Choose to do it differently if you want as an implementation, but I don't see any reason. So we don't have to do it concrete for TCP. We don't have anything just written there like you may do it. You may make it configurable on a socket base.
Yeah, but my key question is: do we document it in the document, or do we leave it open in the way you mentioned? And then we have to make a decision whether the document discusses the TCP case as well.
So my vote would be do it for SCTP, and if you have it for SCTP in a concrete way, it's easily guessable what would be for TCP. So the need to do this for TCP is much less, because there is only the socket name you need to guess, and we provide one for SCTP.
This is a comment to the general discussion about APIs in TCP. I also gave a comment last time, I think, about Cubic, whether that should be configurable or not. So this is Karen Nielsen, I'm from Ericsson, and from our perspective, we have a big issue with the present TCP kernel implementations in that they don't support the APIs that we need. So, I mean, from our perspective, we would very much accommodate a discussion or an initiative where one would look at the APIs. I mean, we do have trouble with that we cannot configure what we want to do on all kernels, which actually makes us not use certain OpenStack software in our nodes because we cannot configure what we want to configure.
Okay, in general, we do have TCP APIs in our charter actually, so that's a heads up. It has been added in the last charter update. We've not looked at socket options too much, but it's in our charter. So if somebody is willing to come up with documents in that space, it's in principle it's within our charter. Okay, I would like to get a sense of the room here for moving forward, but because we have to move forward this document somehow. So can we maybe have a hum, first of all, for the SCTP case? So whether the document should be updated for having a socket option on per association basis. Probably we have to discuss this with some SCTP experts. So that's the first question that I like to hum on, and then let's first do this one. So if you think that this document should have a section describing an SCTP API for per association activation, then please hum now. And if you believe that the document should stay as it is, basically without having such a section, then please hum now. So I was hearing both, so it was pretty, as I would say, the left half of the room was before. It's between left and right half of the room, so that's a pretty unanimous decision. Okay, I guess we have to take this to the list, this question. So there's no consensus here in the room how to exactly handle it. And since it's even controversial for the STB case, I guess I will postpone the TCP question to the list for the moment. Okay, but in any case, then we have to discuss this question again, because if the document has to be added, changed, then we are not ready for working group last call. Also, my suggestion would be, could you please trigger a list, a thread on the mailing list for exactly that question, also whether something should be added here so that we can, in particular those people that were against it, so that they can speak up why they are against this.
Okay, but for the TCP, that's a more general question, I guess, or is it, I mean, if we start to add that, would that not go for in general, or should we just have it in one draft, or?
At the moment, since we don't have a consensus on the STB case, where it's apparently practice to do this so far, at the moment I first like to figure out what we do with STDP. And we had several options what we can do once we agree on what STDP is going to look, whether STDP will have the API section or not. We will then easily, or maybe easily, see what we do with TCP. So for example, if we don't add STDP, we will certainly not add TCP.
Right.
So that's very straightforward. But as I said, please start a mailing list discussion on this, so that in particular that we can leverage here the meeting to discuss this also.
Okay, so just for the STP part.
Start with the STP question, because that's the more straightforward one to me, and the easier one to sort out, in my opinion.
Okay.
So Gary first, probably we should just raise it in TSVWG, which officially maintains SCTP.
Yeah, that's a
just
good point.
Question.
Yeah, that's a good point.
Can we just mention it in the TSVWG meeting?
Yeah, or basically, if you have time there, or if you can sort this out, I mean, it's fine. We are that's one of the drafts where the working groups have to collaborate, actually.
So should we send it to both lists?
Yeah, to both lists, please.
Okay.
Okay, then Richard is next.
Yes, please. So I'm Richard Schaffenegger. I'm standing for Alex Zimmermann, who couldn't be here for logistics reasons. I'm trying to run through this very quickly because I think my time budget is already used up for the discussion last time. This is about Tcpm undeployed options. Next slide, please. So basically, there has not been that much change in the different versions. The most recent one actually includes all the feedback that has been received from the list, especially having some data and some discussion as to the reason why certain RFCs should be moved in the status. Next slide, please. So currently there are actually two different documents describing what to do with such a status change. One is, of course, 2026, which is the one the current document, the current draft follows, as we will see now, as we will see further. But there's also an IESG statement which describes a slightly different process of how to deal with these kind of status changes. Next slide, please. So currently, basically what's in here is what the current draft is describing. All of these RFCs that are listed below the historic status are in the current draft to be made historic based on the guidance given in 2026. However, after reviewing the IESG document, those which are marked red and also those which are marked orange may also be eligible to be moved into informational status. Next slide, please. And of course, the same goes in the other direction as well. Again, 2026 clearly indicates that these list of RFCs should be made historic, whereas the IESG guidance may indicate that the red one is probably better informational. So, next slide. As mentioned, currently the document follows. Currently the document follows the guidance in 2026. The question to the working group and perhaps to the AD is how to move forward with this document. Should the 2026 be followed, or rather the IESG guidance? And there is one RFC in particular, RFC 896, which is of course Nigel algorithm, which has a lot of normative references to it in documents that are way higher numbered, so after the proper document status drafts have been ratified. And if this document is made historic or obsolete historic, this may not be the best way forward, even though, or special case here is that of course many of those RFCs which are listed here in the first section are actually superseded by 1122. But of course at the time 1122 never updated the status of the older documents. Yes, the other way forward may be to obsolete these RFCs and basically mention that they are incorporated in 1122. So that's basically it. Next slide. That's one.
This is the last one.
Yeah. Comments, feedbacks? Martin?
Martin Stiemerling by Accenture, responsible AD. I think, of course, the ISG statement is the right one to do.
Of course.
Of course. No, it's like, that's the clarification on how this is all meant, is like obsolete and historic. I think if you have truly things which are historic, they're easily to be marked as historic by an ISG management action, so it's easy. If you have this, like the first category where you have things where you're not sure, let's say making them historic and obsoleting is the right thing, it's probably the right thing just to let them in the state they are, because if you move them to informational, this means you have to reissue them as a new RFC.
Okay.
Which might be just too much if you say, well, they are there, it's okay how they are there, and just don't touch them.
So the special case here is those mentioned below, which are actually superseded by 1122, but 1122 never actually updated their status because this precedes the status document.
Right, and that's like...
So you would probably have to update 1122 rather than all of these lists.
Yeah, and that's like also another thing. That's a question. Maybe we could figure out if there's a possibility to update the metadata of 1122 saying it's actually superseding those RFCs. That I can try to figure out.
Okay, perfect.
Bob Briscoe. I'm just interested to know, are you, the judgment you're making on whether these are historic or whatever, for instance, I mean, I don't know a lot of these RFCs, but I know some of them, and 896 I know very well, and it just 2 days ago I happened to say to someone in an email, actually the most relevant RFC here is RFC 896, and now you're saying it should be historic, so why is it, in that particular case, just give me as an example, why would that be historic?
896, well, it should be actually, probably if we follow the current status, or the current flow, it would be superseded by 1122.
Right.
But at the time, there was no formal document status, right?
Right, okay.
So that's basically the point. That's also the special case I mentioned with Nathan and Nigel, because again, there are many normative references to it, which probably should have been made to 1122.
Right, but you can say that it's updated by something else without reissuing the RFC, can't you? You can just...
That was the question which Martin has to figure out. Okay, thank you.
So I guess the next step is that we hear from our AD on this.
Thank you very much. Les?
we each use 10-year-old pictures, so you should. But no, Joe is actually the one that you would want to be talking, but you have to settle for me. I'm going to talk about the status of the extended data offset option. Go ahead. So these are the things we're going to talk about a little bit. Both have popped up on the list recently. Motivations and then actual implementation and usage experience. Go ahead. So this slide was made, I think, before the mailing list thread the last couple of days started up, but the reason for using the extended data offset option is that there's just not enough option space, and we thought it was kind of self-evident, especially given the number of things over the years people have wanted to use more option space for, that it would be great to extend the amount of space available to carry options. Go ahead. So the real material to talk about today is the implementation status. And there have been, that we know of, 2 implementation efforts. Joe was working with a student at USC ISI, and Posse has also been working on some code as well, both using the Linux kernel as their basis, and however, taking slightly different approaches to generating oodles of options data. In Joe's work, they're using an additional junk option to fill the space, and Posse's been using a whole lot of no-ops. So the ISI implementation is the one that we have some status to report on. They worked with the 3.13 Linux kernel, and patches are actually available on the website that was linked on the previous slide. There's also a tech report available from the same site with more details than I'll be able to talk about today. The high order results, so they're currently supporting up to a 272 byte option, and well, not compatible with GRO is talked about a little bit further in additional slides, but it's actually semi-compatible with GRO, I think, is the case. So the one important thing to take away, though, is that GRO was not necessarily all that useful. So the performance measurement on this slide shows so 932 megabits with GRO off and EDO on. And when we turned EDO off and GRO on, 940 megabits per second is all you get. So it's not a huge difference coming from using GRO. So I would say it's possibly not the end of the world if you have to disable GRO to use EDO. Next slide. So a little bit more information on the GRO issue. So what GRO tries to do is to coalesce similar segments together. Now the trick is they have to have the same options, and that's actually incorrect for EDO, because the EDO option just tells you how many more bytes of what would normally be the user data is still options. So if you go and coalesce those things, it won't be right. GRO use with EDO caused drops and retransmits, and instead of the 932 megabits with GRO off and EDO on, with both on, throughput went down to 208 megabits. So not too good. They tried an experiment to trick GRO and have the option types change per segment so that it wouldn't be coalescing things. Somehow this still caused packet drops, and the details aren't fully understood yet, still being looked into, but it appears that GRO might be ignoring the unknown options like EDO and coalescing things anyways.
How does it cause retransmits unless it corrupted frames or something?
Well, I think it is corrupting the frames, but
so that you're getting checksum errors.
I believe so, but Joe said his student's still looking into it.
Right, Bob Briscoe. I take it that then it would also be useful to establish how much resegmentation is being done off the node in the internet, because you can only control GRO if it's on your node.
Yes.
Yeah. Okay. Because Because that's sort of the motivation I did for Innerspace and having a sort of record protocol to frame things so that if it does get resegmented, it's still okay.
Yeah,
So it's
that's well understood.
Yeah.
Andrew McGregor. Gigabit Ethernet is now quite a slow NIC for a decent x86 PC. So either you need to move to testing with 10 gig or use a much slower platform. I'd suggest that the much slower platform is a cheaper option, but whatever.
Sure. Sure. And so, Bob, actually, I think the same rules that would apply to fixing GRO would actually apply to resegmenting middle boxes too. So, you know, if there were some general guidance on coalescing or when not to coalesce and how to coalesce, I think it would be applicable to both cases.
Jana Iyengar, I was going to say exactly that. But this is a special case of the general problem of coalescing middle boxes, and GRO is simply another thing in the middle that's doing coalescing. So this, as I read the draft again, this still sticks out as a big question. How do you deal with the failure cases like this?
I think there are sort of two questions. This is one of them, and the way I view it is more of implementation pitfalls. It's not really resulting in changes to the protocol, but it's in about the ecosystem that the protocol is running in and what you need to, you know, look out for. The related other sort of open question in the draft is how to detect corruption of things and whether you do that with a checksum that's part of the EDO option or whether you use some additional mechanism like the John Leslie draft for that.
Okay, the reason I just come back to the mic, Bob Briscoe again. I didn't present Innerspace this time around because we are in the process of implementing it in FreeBSD as it happens, but you know, just a status update.
Back to Jana's point. What we have is
your name, please.
Excuse me, Christian Wittemer, Microsoft. What we have here is that for 20 years or so, people have been deploying things in the network, assume that the format of the head of the TCP header is what it is. So you see that on that particular NIC, but it's probably implemented in a variety of places. That we had this both Sunday evening about the measurement of how ossified the network is, and we should probably put that in the measurement program to see, I mean, when will the thing break? Because it's likely to break, and it's likely to only be applicable in some limited conditions.
Jana Iyengar, just to reiterate my point, I don't think this is an implementation issue. I think this is a fundamental deployment issue. If we can't detect failures, we've lost data integrity.
So you can detect them in all cases here. It shows up as corruption.
I'm sorry?
You can detect them. That's what we were just talking about using this, you know, checksum to detect when things are getting messed up. So it's not, you know, an impossible task.
Okay.
In fact, it's not even a difficult task.
Hi, Tom Herbert. So when you say GRO, you're referring to the software implementation in Linux, not like a hardware TSO or LRO?
I believe this is the Linux implementation.
Okay, so I think these should be fixable, and that's just a matter of a little wiring inside plausible. But GRO is important actually, and I think sometimes, you know, one test will show that it doesn't have a lot of merit. There are certainly conditions where we actually need to have this. GRO is, you know, versus LRO is kind of different.
Sure, and I think getting the rules. So is there a next slide, Michael? Because I think so. You know, Joe made this slide that described, you know, sort of what a hardened implementation would include, and determining the root cause of the GRO issue that they've seen in the testing so far, I think is a key to that. And then further, this final bullet about, you know, what a proper GRO implementation looks like and does, I think that's important to get straight.
Matt Mathis. Depending on checksum errors to detect problems, corruptions isn't good enough. I've forgotten the number, but I'm an author on RFC several years ago, measuring actually IP reassembly hazards. And it's very easy to construct a test case where you send not all that much data and get corrupted data delivered because you managed to get a spurious valid checksum. If this depends on that mechanism, it's not going to fly.
Sure. I actually remember that RFC, and I think the situation here may actually be a little bit better because you can detect fiddling on the path one time and then decide you're not going to do EDO anymore and fail off. You don't need to use it and use it and use it in the face of corruption.
Andrew McGregor. Linux has two things called GRO. And when you need to talk to your implementer and say, look, have you checked whether it was doing it in hardware or software? Because
that was Tom's question, I think.
Yeah.
So these are the next steps.
Yeah. Because the hardware is a lot harder to do the right thing here. It may still be possible, but that's going to be a per device thing to sort out, and that's really a lot of work.
Sure.
So hardware, in some sense, in order to support something like this, we'd have to go and actually change the hardware. So that's why the real advantage here is to get Jira working before you upstream this to Linux.
Let me reiterate Matt's point because I don't think you were thinking clearly in your answer, right? If there is evidence that shows that the checksums will corrupt and then get passed up to the app, so you should default to off. But that's a design question, not a runtime question, because that can happen at any time, right? So the insight from that is I think that checksums aren't going to be sufficient. You may disagree, but do you at least understand what I'm trying to say?
I understand that. I still completely disagree, but I understand. So I guess this is the stuff we have to work in the process of finishing up the document.
Yeah. So first of all, I guess that I personally would also expect that more of these things show up the more we try that. So I personally wonder. The stuff that is done in the end systems in hardware is still a little bit different from the middle box, because in case of the end system, you can probably from the driver also you can maybe find some. At least maybe that you have a NIC that will not support EDO. But one of the high-level questions that is also discussed quite a bit among us chairs is whether we have to change the option format to add some checksumming, or whether we add basically a second RFC that does the checksumming. So we have one proposal that's not presented today, but Leslie has a proposal. And at least to the chairs right now, it's not entirely clear. We are discussing this, but we see a risk that deploying it as it is today might not be possible. And so the options on the table are either add a checksum basically to EDO, or add a second checksum option, and we leave it to the stack vendors then if they decide to enable EDO to do checksumming in addition. Right now the draft, by the way, says that it should be disabled by default, EDO. So that's one of the things to protect against this. But my take is that we need further experience with this, and there is a certain need to come up with solutions in that space, because we have first working groups that might leverage this or not. So that's an ongoing discussion, for example, in TCP Inc. But still, at the moment, we think we need further insight into this and further experience into how hardware basically deals with EDO before deciding whether we can move it forward as it is, or whether whether we have to change the protocol. And independent of this, there is, as I mentioned earlier, there's the status question. But at the moment, we think we will not discuss the status question here in this meeting. It doesn't make sense right now. We have to exactly understand these things, and the more we have of these kind of problems, the more likely it is that the first document would be experimental.
Yeah, and in terms of helping get more experience and progress, now I think the good news is there are sort of two code bases people can use, and so other people can help out with this too.
Yeah, as that's also from my end, I want to back this, as it would be really helpful if further people would test this, would play with it, see where it breaks. So we, as a TCPM, would be very willing to give meeting time for any presentation in that case, and also mentioned on the mailing list. So if you can have an incentive here, the only thing that we can actually offer is offering RFC numbers, but we could discuss this here. So we are really interested in understanding, having data, and any data that would help us in moving forward would be really interesting.
I come over again. So this is kind of related, but I first want to ask, did you try TSO and GSO, or different types?
So I think it's discussed in the draft, and I'm blanking the memory, but the TSO, it copies the same options into all the segments that it generates, right? And so that would not
just blindly copy.
Would not necessarily be appropriate here, because it depends on what those options are that are working. So I don't think you would want to blindly use TSO.
Did you have to disable it for the testing?
I don't know.
That's
Richard might know. He's
so that is kind of a fundamental problem. If you're doing something like TSO or GSO, it works best when we can just copy bits.
Right.
If we have to do another checksum that needs to be computed per segment, and that would kind of disrupt.
And if that code has to look at the option types and sort of go, oh, this is something I don't know, I'll treat it differently than some other set of options that I do know, it becomes more complex.
Right, and we really don't want to kind of force TSO or GSO into having understand options.
Right.
Life is a lot simpler if they just copy those bits.
So Richard Schaffnegger, with my very limited experience with TSO. My understanding is that you can actually basically give the TSO engine a set of data which has to have the same header, including the options, the regular ones. So if you need to have EDO, you can still send basically have TSO enabled, but instruct TSO to just send out one particular packet which happens to have the EDO option with the extend length. It's not as efficient, obviously, but at least there's a workaround.
I see. So depending on what you're trying to do in the extended options area, that may or may not be a solution.
Just to clarify, Richard, are you talking about new hardware that would understand that some of the TCP data is actually options or not?
So I'm talking about existing hardware. I've actually read the data sheets, and basically the TSO hardware must not necessarily understand what's in the data packet if you're sending packet by packet.
But what I mean is that EDO is overriding the data size. I've forgotten the field name of in the TCP header. Yeah, data offset. Yeah, and whereas the hardware will be assuming the data offset is.
No, the hardware simply concatenates a known header and the data that it's sticking into that particular frame.
Yeah, but in the case of EDO, the known header is.
It does what it's told. It does what it's told, so it concatenates the header as in the string of bytes that's been given, right? With the data, it doesn't know anything about the structure of that given header.
But what it won't do is create an invalid TCP header from its knowledge of TCP.
It doesn't have any knowledge of TCP by itself. It simply copies a lot of things.
Other than where the sequence numbers and the checksum live, it doesn't know anything more than that about TCP.
Not even the data offset?
Especially not the data offset.
Okay, as I said, we will keep working on this, and as I said, any implementation work on this here would really be interesting, and we would be really willing to hear more. That's excellent work here, what showed us, but we need more of this. That's very clear. Okay, so if there are no further comments on this, I will go to the individual draft section, and the first one will be stay with Wes with the 793 bis update. And by the way, you will notice I'm not enforcing the agenda here because we have enough time. So please feel free to discuss and let's lose the meeting time in an efficient way.
So this one's a little bit bigger than the extended data offset. You can go to the next slide. So this is a history of my attempt to update RFC 793. A long time ago, and continuously for a while, people would periodically mention, boy, RFC 793 isn't very good reference anymore for what TCP actually is and what TCP implementations do. And people would joke about replacing it, and I didn't realize it was a joke. But sometime in late 2013, I put an individual draft together that didn't actually have any protocol content. It was really just the proposed game plan for how you might tractably go about replacing RFC 793 without losing all your hair. And we talked about it at the Vancouver IETF, and surprisingly, people didn't think it was that crazy, or at least they were polite and didn't tell me how crazy they thought it was. And I came away thinking it might actually be a good idea. So since then, there have been several more revisions posted. I'm up to the fifth. And I think it's time to adopt as a working group item. So the next couple slides, I'm going to give you, go to the next one, Michael, what that proposed plan was. And so the rundown of it is, if I had to summarize it, the strategy is to write as little as possible. So I took RFC 793 as a basis and want to use patches to it from the other documents that have updated and superseded parts of it over the years. And so the goal is really to bring in the text that's already been beaten up and agreed upon and has IETF consensus from many working groups that developed the changes to 793 over the years, and to, as directly as possible, bring in the text from the other RFCs and errata and just apply them to the 793 basis. So the do no harm motto applies, I think, because I'm trying not to introduce any new changes that have not been approved by past consensus. So already on the list a couple times it's been, people have piped up with some answer about other things we should be doing in this document that, like, actually I think extending the option spaces was one of the things that someone said we should do if we're opening up 793, and I think the response is sort of, no, we're not really opening up 793 for changes, we're just porting in the patches to it that have already accumulated over the years and just smeared out across 24 documents. So I want to minimize the potential to do something bad, and also, if it's successful, this will be the most boring document that the working group has ever done, because there'll be nothing to debate, since it'll be things we already had consensus on.
Never, of course. Matt Mathis. One of the issues is there's a lot of little details of the specifications that were actually worked out on the mailing lists and never made it into the documents. How hard are you going to try to recover those?
Well, and if you can point some out, and you know,
they actually predate my expertise in the area.
So
most
that's
of them
be
happen.
So certainly, like the TCP/IP mailing list archives from the 80s are available, and we can do quick greps through them for certain things. But it's hard to find things if you don't know about them. And, I would say that for the most part, those kind of things would wind up out of scope, and the right path would be to, if they're worth documenting, document them separately in the working group, get consensus on them, and then fold them into this. Because my position is that this is for things that there's been demonstrated consensus on. I don't want any new consensus.
Yeah, but there was consensus on things in the mailing list that appeared in the code.
Hi, my name's Tim Shepard. Is the intent to preserve all of everything that's there in 793?
So what I did, if you looked at the diffs, for instance, I did not preserve a lot of the introduction discussion because some of it was about really more than just TCP, and it would take a lot to update it and bring in all of the necessary changes. So this is the normative protocol spec. I think it was section 3 of RFC 793 that describes sort of what the protocol looks like, what the names of all the header components are, what the state machine looks like, and then what all the behaviors are when you're in certain states and certain events happen.
So then we would not obsolete 793, just obsolete part of 793?
I think we would obsolete it because the text that's not included is purely descriptive, informational, hand-holding text.
Yeah, I didn't.
And 793.
I just went and I pulled 793 up and quickly looked at some of that early stuff in 793, and I thought I'd come and ask you.
It's quite good stuff, right?
Yeah, it is quite good stuff.
And 793 doesn't go anywhere. So
yeah, I understand.
It'll still be there, and we can have a
well, but see, marking 793 as obsolete is then the wrong thing because it becomes some parts of it not obsolete. It becomes
the protocol part of it is, and I think the protocol part is what we try to market as, the standard or the obsolete.
Yeah, I don't know if we have a mechanism of saying only part of a document is obsolete and the rest of it is informational. It would be sad for that stuff to go away or to become something that nobody ever looks at again because the indirect directive for the document says it's obsolete.
I think the odds of that are
so, maybe the correct way would be to say you obsolete the document, but you mentioned in the updated version that there's interesting text in the obsolete.
That's actually in there already.
Yeah.
So.
Okay, then. Richard Schaffenegger is author of 7323. He actually did this same way in the update to 1323, that we basically obsoleted the old one and referenced some of the introductory text in the new one. So I think that's the way forward.
David Borman. The other comment I would make is if people felt strongly that they wanted to have that text still available in the updated document, it could be copied over into an appendix, which is not part of it, and just paste it in verbatim, and that way stay with the document if that's what people really want.
My position was actually that it's great text, and it's useful if you are just learning about TCP. But now in 2015, there's all kinds of textbooks, Stevens books, right? And people have other ways of learning about TCP than reading the introduction to 793 that actually in some ways more detailed than that introduction.
Yes, but also different.
Absolutely.
And I've many times pointed people at RFC 793 who learned networking out of those textbooks and in some sense learned it wrong.
I see what you're saying.
Figure 1 is great. Is that going away? I think what you've told me is yes.
Which one is figure 1 then?
The layering.
Yeah, that's not in there.
Yeah, that's very sad.
Well, it's not a part of the protocol either, Tim. It doesn't show IPv6. It doesn't show a lot of things that have changed since then.
IPv6 doesn't change.
Mm.
Just a very quick opinion here. So I like to have the document as short as possible because the alt text is still available on the internet. It will not disappear. And if you actually want to write, if you actually want to read the standard to implement something, then you should find the information quickly.
So the current state, and this is actually an overview of the changes that made. So the first revision actually is when I did all the XML to RFC conversion of the 793 text. So I copied it and pasted it directly into the editor and started typing pieces of it in XML, and that was the longest and most painful revision. And if you wanted to verify that that process didn't change much from 793, that's the revision you would do the RFC diff on for 793. I did that myself and tried to vet it, but other sets of eyeballs are welcome. Then in version 2, I went through the errata that are in the RFC editor database, and of the ones that are marked approved or held for document update in the errata system, I tried to roll those into the second revision, and there were quite a few of those, and I enumerated them in part of the document. Then in version 3, I tried to bring some things from RFC 1122 and other documents that talk about the urgent pointer, and I pasted in the 1122 requirements for what you need to do in your TCP implementations into the back of the document, because I thought that was important to, well, there are some updates to that accumulate, for instance, regarding the urgent pointer, which is why I brought it in there. Version 4 was, I think, a easy patch. It was just about initial sequence number generation and bringing a text on what you need to do there from C528. And then version 5 is a little bit more recent, and Joe actually has given me some good ideas of things that need to be improved in there, but the main goal there was to deal with maximum segment size and path MTU topics, which are not touched at all in the original 793. So this is kind of a new section, and I tried to paste in pieces from relevant RFCs there, and it still needs a little bit of work. So the foreplan, I think one of the most important things to be done still is to capture all the other 1122 additions to what it takes to be a TCP. And then there's things like, well, it's not 1323 biz anymore, is it? But other important documents that a TCP should implement, I would point to, not try to incorporate, because they're not strictly required for interoperability. Incorporate the relevant parts of ECN, and well, there's an errata 3305 that's actually directly related to this document that Fernando has been trying to get the group to address for a while now on sequence number validation. And I guess if that doesn't get adopted, I won't be addressing that errata, but it's going to send a list of things that might be done. There's a whole bunch of other things listed in the internet draft if you're interested that are on the radar.
And I'm curious if you mentioned the DSAC RFC. I actually don't remember the number. The reason I ask is it turns out DSAC is an extremely useful signal for discovering if there's a bug someplace else, because often the signature you get is duplicate data. And there's a small number of, well, a large footprint of a small number of vendors that don't do DSAC currently.
Yeah, so I think that what would be included here would be that you should do RFC 7323 and in conjunction DSAC, right? But I don't think we would be trying to incorporate the spec for DSAC.
just realised that there's a sort of negative side to doing this. 3168 ECN is a good example of this. There may be others where it covers TCP and other stuff. And so if you update it, people get confused as to which part of it is updated. You have to be very clear, you know, because you're not obsoleting it.
1122 has that problem even worse than EPN.
Yeah.
1122 contains stuff up and down the entire protocol stack.
Yes. Yeah. And so, have you got any ideas on maybe breaking it down into multiple parts that are modular in some way rather than one monolithic thing? So that you
I had not thought about that at all.
Well, it may be a better way.
That's something we
it can
should
reflect
discuss.
the implementation modularization of it. You know, it may help.
Yeah, it probably would be more prone to, I mean, refactoring like that would be more prone to doing what I said I was trying to avoid of not writing new text and not introducing errors and things in the process.
Janai, I'm sure you thought about this and kind of trying to figure out for implementations that do 793 perhaps don't do some of these others that we want to include. What happens to them? Are they considered not TCP at the end of this process?
Well, so they may already not be TCP. So the RFC 1122 actually has a checklist of things you need to do if you're TCP, and so if they aren't doing some of those, they frankly aren't confronted even with that already. So it depends on what you're talking about specifically. But
I don't have one specific thing, but they're adding a lot of things that may not be.
for instance, Enable is an example of something that's not in 793 is
Sure.
1122.
And a couple of condition controllers isn't.
They're not really full TCP. Yeah.
Still in route.
Yeah. Sure. Do you think it's a problem if they become not really
No.
they're not modern TCP, right? So we can agree on that.
I would love to get rid of those ones and actually not call them TCP. Maybe that's what we should do.
Yeah, so
I'm happy to see that.
I think that's how you describe this, is it would define what a modern
Okay.
TCP must do.
That'd be wonderful to have.
I'm wondering if we could perhaps extend the document status to, I noticed it's the later RFC that says obsoletes and refers to the previous RFC. I wonder if that could be extended to obsoletes RFC, some number, comma, sections 3, 4, or 5.
Area director doesn't look happy.
But it seems like if you don't have that mechanism, you've got a problem like what you do with the. You can only go 1122.
We can certainly put a section in here that says, for clarity's sake, here's a list of the other RFCs that we specifically obsolete section 4 of this and section 5 of that.
But what's going to happen? Is this going to say obsoletes 1122 or not?
I would not plan to have that in there now.
Okay. But you would say
it updates 1122 in some cases because things that 1122 says to do has changed in some cases. So it does update 1122.
But you would say obsoletes for 793 and updates 1122.
Yes, because it will obsolete 793 in its entirety. But
not sections 1 and 2, but yes.
So, in summary, I think that this is progressing, but it's slowly. I don't think there's an urgency unless someone, this is your chance to run to the microphone and say that the urgent needs to be done quickly, but I don't think so. Feedback has been relatively positive. I think people generally see value in doing this kind of house cleaning. So please decide to adopt it as a working group draft. And I don't think it's a hard or scary task, actually, if we can agree on scope and stick to it. You know, by that I mean leveraging the text that already exists in other RFCs rather that have been accepted and sort of grouping them together.
Which one, John? It's a question about updating 11.22. So for example, is Nago going to be in this space or it will stay in 11.22?
No, don't come into this.
Okay, so there will be some overlap with 11.22. We don't obsolete 11.
It will be updated, and in terms of all the material in TCP 11.22, it will be my intention to incorporate those into this, because all of those are things that you should be doing or must be doing or must not be doing in TCP implementation.
I think so.
The goal is to have way less documents that you need to read if you want to write a TCP from scratch.
So the only thing I want to mention is that because it's not a hard task, it might be difficult to find reviewers because it's boring to read because it will take time. But it would be probably useful to find people who've been involved in the documents who get in the text from to actually look at your document and make sure you've got the right piece of text and not only part of it. So that's a task for the chest problem.
Yeah, ensuring proper review is going to be difficult.
Do something incredibly stupid and stand up and prompt review on this. But I think it's really important to be done. When we look at the maze of updates of things that, and it's not a big maze, but there are some fairly foundational documents that are going to stay updated by on. There needs to be text in this document that's very clear about that update doesn't actually change, it just clarifies. So when you follow the update pointer forward, there's something in a section 1.x that says, don't worry, if you've already implemented this other thing, don't freak out. Read this to make sure you did it right, but don't freak out.
I just want to speak in favor of this. I think it's a good idea. I'm glad you're doing it. There are a button for punishment, apparently. During my time as part of the university editor, I became aware that the updates and obsoletes tags have not been uniformly applied in a period where it was just very carefully done and bookkeeping and that. And I just wanted to see whether is that what you're relying upon, or it seemed to recall there was an RFC that actually went through in a more detailed due diligence on all the pieces of TCP. Any room in that?
Yeah, so the TCP roadmap RFC has been sort of a nice thing to refer to, because that might be what you're...
Yeah, that's what I'm thinking of, yeah.
So I've been one of the authors of that. So it's actually a good way of trusting out some of those other RFCs. Your RAN system is quite good too. You have to look at not only your RAN on 793, but all those other documents. And in the long run, holding as much as we can that has been accumulated into this will save other people a lot of time and frustration. I don't know if we'll catch every single little thing, but I think we've come awfully close because a lot of work went into the roadmap is trying to catch every single little thing. But like you mentioned, the RFC editor database and the pointers that captures are a subset of, they're a large subset, but they're only a subset of what needs to be captured by, not solely relying on that.
Yeah.
To answer your question.
Good. And then about reviewers, I'd like to suggest specifically see if Bob Braden can look at, and also Sam Fall, because when he updated Stephen's book, I think he went through and did this. Kevin?
I'll take that. Yeah, with regards to the comment that Tim made, Kevin Fall's view, it was updated in 2011 after 7 years of work, and there was lots of TCP stuff. So some of what you're doing here, I also sort of tried to collect all the stuff together and did kind of the best as I could, and even rewrote the pictures so that all the bits have, the latest versions of the things. So I was just this morning sending an email to the publisher people saying, I wonder if it's going to time to take another look. And so I'm not sure I really want to sign up for that. But West, I don't know. So there's because it also covers other stuff that sort of aged a little bit in 4 years. But if you want, I'm happy to discuss that and what I did to try to get it all together.
Yeah, despite some of my earlier questions, I was just weren't in with a word of encouragement. I think that this is all very good if you're going to do this.
I actually think it's positive if people are skeptical and have questions because you should.
Maybe we should be questioning your sanity.
Yeah. They're clearly not all there.
But we should, but this, you know, we should be thankful that you're diving in. That you know that a while ago, actually, that you're as far along as you are. So I do want to give a thumbs up to this.
Generally, I said this earlier but I'll say it again. I think this would be very, very helpful. And I'll give you a particular instance of why it would be really helpful. There were some folks not too long ago who told me they implemented TCP. And I said, what exactly did you implement? They said they implemented the TCP. And I don't know exactly what they did. So that gets me worried because there's a fair amount of traffic that's using this TCP. And we're fantastic to have something that's more updated. As a side note, we were just sitting there and talking about whether SAC will be required or not. I look forward to have one of those conversations going forward.
Okay, so I guess the first good news is that this is also what we're in of our chart file, even if it's a major work item. It's very clear that this is what Tcpm should do, in all. So first, before we discuss the adoption, I have one question on the process issue. So it was mentioned various times. The challenge is actually not so much in producing the document, but verifying that it's really correct. So that's why also the chairs we discussed a little bit about how can we as group actually ensure that when we review that it's the best of all the knowledge. Idea that, for example, we as chairs have is that we will collect as part of the introduction process and we will for use. In cases it will probably be because to confirm that what Wes did is the right thing. But we do need people that look at this and look at it from all angles. So are there any other views on how this group can finally review this document? Okay, then as I said, we will, as chairs, we will, as part of the adoption call, we will ask for reviewers. And the first thing I will do right now is, as the first question, I would ask you for a show of hands. So who is willing to review this document? As if we adopt it. So, okay. I see about 10 people. So I will not note down the names right now. This will go to the mailing list, but 10 is excellent. So that then I will ask for a hum right now, but as I said, the chairs think we will do the actual adoption call on the mailing list. So that's a little bit unusual for what we do, but we will ask for the group for explicitly plus ones for this one. And the reason is not that we don't believe there is consensus, but as the part of the question will be, we will try to nail down the people that will review it. So that's why we will do the actual adoption call on the mailing list. But obviously, I will ask the question now here in the room. So I will ask the usual two questions. First, about the adoption of the document in the scope that has Wes explained. So in particular regarding what is in scope of the document and not, and obviously I will ask in a second if there are any concerns with adopting this. So the first question, so if you think the TCPM should adopt this document now, then please hum now. Okay, this is a very strong hum. And if you have any concerns regarding an adoption right now, then please hum now. Okay, so for the record, there's no hum against this. So as I said, we will follow up on this on the mailing list, but the consensus here in the room is absolutely clear. We will adopt this. Okay, then I think we will move forward to David.
Okay, hello, I'm David Borman. I work for Quantum Corporation, and I'm presenting today a proposal that I've come up with for a TCP four-way handshake. On the next slide. The things I'm going to talk about, one is the TCP four-way handshake itself. I'm going to talk about data delivery to the application with regards to this extended negotiation, about TCP options relating to this, and there's another item in the document about adding a new unknown option. The current draft is there listed on the slides, as well as my email address. So the background about this, as we've already had a presentation about EDO, the challenge is that you cannot expand the TCP option space you cannot expand the TCP option space in the initial SYN in a compatible way such that it will interoperate with legacy implementations that do not understand the extended option space. There are many reasons for this. I've kind of gone through it in my own research. The biggest one is that there's no place to put the extra data. TCP does not have its own length. It's computed from the length of the IP packet, so there's no opportunity to have sort of a delta between those two as a place to put the data. If anybody can come up with a clever way to add additional space into a initial TCP packet, that would be wonderful, but so far nobody has. So with that, if you're going to have additional options, they have to go someplace else, and the only other place is in another packet. And there have been three approaches that have basically been proposed and looked at. One is a parallel SYN approach, where you send two separate SYNs, one connection which does not have the extended, the other one has the extended option space, and you shut down whichever one doesn't make sense for how the other side responds. The second option is listed here as a companion packet. It's a secondary packet that's sent along with the SYN. It's not a SYN itself. This is Joe Touch's one, where the packet is sent with no flags, no SYN flag and no ACK flag, which hopefully will be ignored by legacy implementations, but extended implementations would understand that and be able to take that along. The third option is extended negotiation, and that's the one that TCP four-way falls into. Next slide, please. There we go. So the goal of the four-way handshake, it was motivated by extending the TCP option space and finding a way to deal with EDO during the initial negotiation. A secondary goal was also to do this in a way that wasn't tied specifically to just EDO, but provide an extended negotiation mechanism that could be used for other things besides this. Next slide. So let's take a quick look at the traditional three-way handshake in TCP. A client sends a SYN packet and enters SYN sent state. The server gets that SYN, sends back the SYN ACK, and enters SYN receive state. And when the client gets back that SYN ACK, he enters established state, sends an ACK, and the server enters established state. Should be pretty straightforward. Everybody understands that. So if we go on to the next slide, this is the proposal for the four-way handshake, for how the negotiation. The things that are in red are what changes. So when the server receives the initial SYN, that packet will contain an indication that the client understands how to do the extended four-way handshake. At that point, the server will send back a SYN ACK. It'll be the same SYN ACK packet, except it has also the four-way information in it. And when that comes back to the client, he can then choose whether he wishes to continue with the four-way handshake or just do a traditional three-way handshake. If he continues with the four-way handshake, he then sends a SYN ACK, and this differs from the traditional three-way handshake that we have the SYN bit set. At that point, the server, when he gets that SYN ACK, what differs there is that he now has to send back an ACK, whereas with the three-way handshake, he's done at that point. And then finally, when that ACK comes back to the client, he enters the full established state. Yep, okay. So there are a couple of things. There is how does this deal with the options? I'm going to get to that. But there's also how do we deal with delivery of data to the user application. And in the initial draft of this document, I had a bunch of text in there talking about how it introduced a half of a round trip delay or around one round trip delay in when you could deliver data to the user. And as I thought about it since then, and what's in this document, is that it's not actually the entering of that state with the label that says established, that says it's safe to send data. It is in the three-way handshake, you send a SYN, and when you get that ACK of that SYN, at that point you say, it's safe to, I've now established this connection to the point of I understand there's somebody real on the other end. And on the server, he sends his SYN ACK, and when he gets the ACK, at that point he says, okay, we're now at a point. So it's the sending of the SYN and receiving an ACK of the SYN that really indicates we're at a point where we can start delivering user data. So with the four-way handshake, that still happens in the first couple of packets. So it happens at the same point. So there really is no point in delaying delivery of data to the user application. So the important point is it's receiving the ACK of the SYN that says it's safe to deliver data, not transitioning to a state that says established. Okay, I've got a question.
Yuchon Chen, can you go back to the slides up? Yeah. So in the pre-established state, can the client receive data at that point?
Yes. So with the next slide, once we've entered pre-established state, we've received the ACK of our SYN, so any data that he has received that came with that can be given to the application at that point.
So why don't they just enter the established state? I guess it's a little bit strange to me that we are in a pre-established, but you can actually receive data. Yeah.
The difference is that, and I'll get to this later on, it has to do with the options. Because when you have your initial SYN packets, the packets that contain a SYN bit are reliably delivered by TCP. Once you get past that point, they aren't. One of the challenges with TCP options in general, with midstream deciding I want to enable a TCP option that I haven't never put on this connection before, is it's not synchronized. And if you need to have an actual negotiation, that requires adding a whole new mechanism for negotiating options in midstream in TCP, which currently is not there. Whereas in the initial handshake, the packets with the SYN bit are reliably delivered. So there already is an inherent negotiation, inherent reliable negotiation. This is why things like 7323 say to do expanded windows, for example, the window scale, you have to exchange them in the SYNs because that's going to happen reliably. So as I go on, I'll talk a little bit more about that piece. But the important point that I'm trying to make right now is that unlike my original document, the current document says you can start delivering data at the same point to the application. Okay? Okay, so did I already say all this? I think I already said everything that's on this slide about pre-establishing data, so let's move on to talk about the options and the SYN packet. So as I said earlier, packets with the SYN bit are reliably delivered. Hence, any TCP options that are in them are also reliably delivered. And that's important if you're doing a negotiation, is that you have some reliability in that. And if you read in 7323, it talks about, in the three-way handshake, for negotiating options, the client puts in the options it wishes to have. The server, when he receives that, picks which options he's going to acknowledge, basically, and then sends those back. But if he knows about other options that weren't received in the initial SYN, he does not send them back. And that's actually just an optimization for the implementation, because when you have just the three-way handshake, and if the document says it's the presence of those options in the SYN, and you only have 2 packets with the SYN, there's no point. If you didn't receive it in the first SYN, it's not going to get enabled anyway, so there's no point in sending it. However, with the 4-way handshake, what it provides is a second opportunity for the client to send an additional packet containing the SYN bit, allowing it to send options that it was not able to send in the initial SYN because of space constraints. So the client sends his initial SYN packet and indicates he understands the extended data option. The server then can send back a whole bunch more options if he needs to, because he now knows that the client understands EDO. And so he can include options that weren't included in the initial SYN. And then when the client gets that packet, he now knows that the server does understand EDO, and he can then include the options that he did not include in the initial SYN because of lack of space, if the server has said it understands that. And that's the key point, is that the TCP 4-way allows the additional options that did not fit in the initial client SYN to be continued to be negotiated in this second SYN-ACK that the client sends. And that's really the crux of the whole point of this document. There are some changes to the TCP state machine to support this. You're not forced to use the 4-way. You only use the 4-way handshake if you need to use it. On this particular slide, I will say the labels I got reversed. The first is actually the passive. The second is the active. So in the passive case, which is the server, he receives the initial SYN, and he does an immediate transition state to decide, is he going to continue with a 4-way handshake or just go with a traditional 3-way handshake? And I call it a transitional state because he enters that state and then immediately leaves it for one of the other two. If he decides to continue with the 4-way, he will enter a new SYN-ACK sent state. And if no, he just goes to SYN received like he always did before. On the active side, which is the bottom one with the wrong label, when the client sends his initial SYN, he indicates whether or not he can support the 4-way. And when he gets that SYN-ACK from the server at that point, he will then say, am I going to continue with the 4-way handshake, or am I just going to go on to the regular established state? And if he says yes, he's going to continue, he then enters the pre-established state. And this is the state where the client can, at this point, if data came back, he can start delivering that data to the application. But he's also going to send a packet, a SYN-ACK instead of just an ACK, which will allow him to include additional options to continue to be negotiated or met. And then when he finally gets the final ACK back, then he will enter established state. So that's the main change in the state machine to support this. Next slide.
That's already the next one.
Oh, sorry. So it's not perfect. There are issues. If you have something that's a one-way option negotiation, where the response that the server sends is dependent upon what it receives from the client, then the server can't advertise that in his SYN-ACK that he sends back. The client would then have to send that in the additional SYN-ACK in order to do that one way, because if it wasn't in the first one, then he has to go to the second one, and that introduces a 1 RTT delay in negotiating one-way options of that sort, as opposed to something like the window scale option, where it's not negotiated between the two. Each side is just saying, yeah, I understand it, and here's the value I'm going to use. In that case, it doesn't matter the order of who looks at which first. So one-way option negotiation would be one issue. The other issue is if your data is going to be dependent upon what's getting negotiated in the TCP options. The example that I think of is encryption. If you are negotiating, if you have options for doing keys in TCP, to do encryption in the TCP session, you can't start encrypting the data until you have that negotiated. And if that gets deferred, then so too with delivering the data. Now, we don't currently have that, at the TCP level. But that's just the example as I thought about where would this fall apart. So it's if you have an option where the data is dependent upon that option.
Tom Herbert, what about something like TCP authentication? We do have that as an option, right? So it seems like sending data before the connection negotiation is complete is a little dicey in any case, right?
Yes, that's correct. So if you're doing authentication of the option, you can't deliver the data until you've finished that negotiation. Now, one of the things I didn't mention in here is that when you are deciding which options you're going to include in that initial SYN and which ones you're going to leave out, what you would want to do is put into that initial SYN the options like authentication, the things that you really want done up front. If you're doing the TCP, the fast
open.
Yeah.
So, but if you remove the capability to send data in pre-established state and just say that option needs to complete, you need to go to established state before sending data, it seems like the only cost of that would be the extra round trip. Is that what we're trying to avoid here?
Yes, it's the extra round trip time.
I wonder for robustness if it would be better to just go with that model. Well, but we're already using this facility to extend the TCP option. So I mean, there's got to be some sort of give and take here. My concern is that this is trying to extend option negotiation, but then with the caveat that we can start sending data in the middle of the negotiation before it's complete, which sounds dicey to me.
Well, there have been proposals in the past that basically do the same sort of thing, but I think it's actually a five-way handshake, effectively, where you send your initial thing, and then you find out what he supports, and then you basically do the three-way handshake. So you introduce an extra round-trip time to understand what the other side is capable of. And in that scenario, you're always introducing the additional round-trip delay. The goal here is to minimize the scenarios in which you have to do that full sort of extra round-trip delay and say that in a lot of scenarios where you're not actually needing to use the additional option space, it just falls back to the three-way handshake.
Bob Briscoe, BT. I want to try and have a sort of one-to-one conversation to explain the email I sent that you didn't understand, and the thread just ended way back about a year ago or something like that. The point I was trying to make is that because you're starting or allowing data to start while you're still doing the handshake, I just gave examples. If you're using TFO, and even with IW3, you may have about 7 seconds of data before your four-way handshake completes, and you've started to use the options. If you're using IW10, you may have something like 21 segments already sent before you've done the options. And that's already 95% of connections on the internet are finished, even before you've finished your handshake. They haven't got any more data to send. So there's no point having extended the options when you haven't got a connection anymore.
Right. If the data is dependent upon the options that are being negotiated, then they will be delayed.
Yeah, but it's not just the data, it's the connection hasn't even had the benefit of whatever you've negotiated because you finished it.
Right. It really depends on the TCP options. You know, if you're doing the point is, if you are able to actually send the data, then the implication to me is that you've already met the criteria that you need to be able to send that data. Okay?
Or you can't send that data because you wanted to negotiate some options, and then we haven't solved the problem that we're trying to solve. That's the other problem, the other way of looking at it. Yeah.
If the data cannot be done in parallel with completing the negotiations, there are different. Not every single data option has an impact upon the data itself. And the point is you can prime the pipe with the data even while you're doing the option negotiation. If you're going to send all your data and it's all going to be done within the three-way handshake.
No, within the four-way handshake, that's the point.
Right, but if it's within the time frame of the three-way handshake, it's all going to happen, then you don't need the four-way. If you need additional options that need to be negotiated in order to be able to generate and send that data, yes, you have to wait.
Right. So I guess the summary of that conversation is that the four-way handshake may be useful for extending options during the handshake that are relevant beyond the four-way handshake, but it may not cover a lot of options that...
The hard part about this is having a generic discussion, because you really have to look at individual options.
Yeah, exactly.
And you have to look at them within the context of what is it you're trying to do. And it's not in my presentation, but in the document I went through and listed all current TCP options that have been approved and made some comments about each one of them. And if you have new options that are being defined that currently don't exist, then the point is, if we have this four-way handshake, each of those new options will specify how they operate within the context. How do you get them negotiated if you were doing it in the four-way handshake?
Okay, so without going into each of those options, and I did comment on them in that email, just the more general point that Lars made last time, and a number of people have made, that one of the requirements for this is to have options on the SYN without adding extra latency, and I don't think this meets that requirement.
Conversely, if you do dual SYNs, if you do a side packet, then you're getting... One of the things I really like is determinism. I like playing things that are deterministic. That's why there's additional states in here. You know how to transition from point to point, where you are with each thing. You know whether or not it's safe to send those additional options. You don't have to worry about, I've got two connections. You don't have
but
to, you know.
I don't think there's any non-determinism in the other proposals.
Yeah, so
let's
for the moment focus on this proposal here.
Right. What this does, as opposed to your proposal, is it keeps everything within the context of a single TCP connection. Okay? And I think that's important. You know, so that's being posed within that. Okay?
Michael Welzel, I am now stepping on very thin ice and risking that the whole room goes, you have never understood TCP, because it's but is it, yeah, I'll take that risk. So could it not be possible to implement what you're doing here without even changing the standard by doing this simultaneous open thing? So have SYN, SYNAC, SYNAC?
You could, and in fact, that's okay. But I've got a couple of comments on that. One, that's actually called a simultaneous open.
Yeah.
And exists in the
that's what I mean. Yeah.
The biggest challenge that I see right off the top with that, and why I didn't do that, and in fact, originally I had it being a bare SYN instead of a SYNAC, the server's name back to SYN. However, in this world of middle boxes and firewalls and NATs, a lot of places allow an outgoing bare SYN, but if they see an incoming bare SYN, they'll drop it. And the hope is that with using a SYNAC and not having the crossing bare SYNs,
that's enough of a reason already.
Okay. So I want to go a little further on Bob's question, and you can correct me if I'm wrong, but I actually think that you wouldn't necessarily use the four-way handshake on every connection, because once you've completed a four-way handshake with enhanced SYNs or extended SYNs or whatever you want to call them, you can cache that information, and you know that the server in the path probably still supported on subsequent connection attempts, and you can just go for the enhanced SYN right away after you've got a four-way handshake to work the first time. So I think for a lot of connections you could wind up using enhanced SYNs right off the bat.
Right. And that's actually, thank you, Wes, that's in the draft, the fact that if you have a priori knowledge that the other side does support the extended data offset option, then you can actually safely send it in the initial SYN, because you know it's not going to misinterpret it. Just to remind everybody, the danger of sending and using the extended data option in the initial SYN is if you send it to a legacy TCP that does not understand it, that extended option space becomes part of the TCP data stream. And that's the problem. But if you know the other side supports it, then you know it won't misinterpret it.
Yuchon here. Can we go back to the state transition graph of the four-way handshake?
Yes.
Yeah, this one. So what happens if when the client sends the SYN ACK in pre-established state and some mailboxes drop it? Does the connection eventually just time out in pre-established state because that SYN ACK cannot be reliably delivered? Or
if the client sending back a SYN ACK is constantly dropped, then that's a problem. And there would have to be additional stuff put in to say, how do you continue if you don't get a response, and potentially have the ability to say you send back an ACK and you turn it into a three-way handshake. And then you lose the ability of those additional options.
Okay, so instead of just consider as a sort of a handshake failure, you trying to fall back to a regular three-way handshake.
Yes, that would be the way.
But that might not be a viable option for some application who have to get all the SYN options through before he can do anything useful. So that might be an option for the application to specify at connect, like, try four-way handshake no matter what. I'd rather get a failure or fall back to three-way if possible.
It would be possible because he knows that he supports it to actually send a SYN and contain those additional options on it. I mean, to send an ACK with those additional options. The only caveat there is that packets without the SYN bit are not reliably retransmitted.
Yeah, so that's why I meant...
That could be designed that way.
Okay, but that's not in the draft.
That's not in the draft. When we look at this four-way handshake, it could be designed to say it's a three-way handshake, and we go to established state here. We don't have this pre-established state, but we say we're still going to continue to do option negotiation. We can still send things back and forth. The challenge is right now, the way most option negotiation is specified, if there's a negotiation, is it has to be exchanged in a packet with the SYN det set.
So I really like the alternate design that you just talked about, and then if that's okay with the application to say, let's continue to negotiate the option that's supposed to be in SYN but now in data, but we cannot guarantee it will be delivered reliably, that would basically take out all these new states. My rationale is that I think the TCP state machine is really complex, just trying to review RFC 793. Adding one state is not a trivial task. So that's just my comment. I would prefer the alternate design you talked about.
Okay, up to the front, Mike.
Yeah. Well, let's go again. Sort of coming back on what Wes said as well, but I think you were agreeing with it, so question can go to either of you. The fallback position you said when, if you know that the server has accepted this in the past, and so you go straight for a SYN with extended options in it, then you still have to have a fallback if you're actually hitting, a server, the IP address has changed or whatever, and something else has taken over that IP address or whatever, So you still have to have a fallback, and you can still do that because until the three-way handshake is completed, you can still reset that connection and then start another one if the server looks as though it's not understood what you just said, right? So you're back to a position where, why don't you just do that all the time? And send a SYN without the four-way handshake, just with a three-way handshake and abort it. If the server, and start another one. I don't see the need for this.
If you send it and you abort it, and then you try and reestablish the exact same connection with the same ports, you now have to deal with what if I had retransmitted that initial SYN, what if packets get reordered. There are additional things to deal with.
that they can be dealt with. They are dealt with.
So one comment I should make is that my goal with the four-way handshake is not that I think the four-way handshake is the end-all and that this is the solution we should adopt. My purpose is more to step back to the theory that I would like us to have a solution that allows us to do this within the context of a single TCP connection, to have the extended options. And I'm also trying to think towards the future, where do we eventually want to get to, not just what's the first step we can take. And where we want to get to may very well be a path that involves breakage along the way. And then it becomes a question of, can we find a way to mitigate that breakage and, over time through transitions to get to where we'd like to be. And I think that's the more important. And whether or not TCP four-way is the way to do it, I don't know.
I have the same goal, and sending a single SYN with extra option space in it and then falling back otherwise is what I'm trying to get to.
Yeah. I wish TCP had a much larger option space to begin with, then we wouldn't have this discussion. I wish its length wasn't computed from the IP packet, because then we'd have a way to put additional stuff in. The reality is there actually are several versions of TCP out there, of the header. We don't have just one header. Just the introduction of the window scale introduced a different TCP header. When you're negotiating the window scale, you're actually negotiating a different interpretation of the TCP header. And we don't have a version number. We don't have a versioning system. We're just doing incremental updates.
Also, looking at the time, we have one presentation to go, so could you please be very short right now?
Okay. I want to make an observation about something you said that isn't quite correct.
Okay.
And I don't know if it creates an opportunity because I haven't thought enough about it, but there is a very simple algorithm for reliably delivering options on any other packet. And the issue is every time you have to label them with a sequence number, and every time you retransmit that sequence number, you retransmit the options as well.
Right, but that only works as long as you actually are sending data. If it's a one-way unidirectional data option, everything coming back, the sequence number never changes.
Okay, that was my. That was.
That's
that
why.
That was my.
Right, that's why a whole. Right, you have to do some way to get those reliably delivered to do that.
That could be done.
Can we just flip through and make sure I cover
Yeah,
everything?
I would, as I said, I would like to complete a presentation pretty soon, so please be very brief.
So the last thing that I wanted to say was, in the document, this one, yes, this slide. In the document, I talk about using a bit in the TCP header to indicate support for the four-way handshake. That's not the only way to do it. Initially, I just kind of said, well, here are different ways we can do it, and then some advice said, well, put one in and put the others as alternates. So there's more than one way to do it. I'm not married to any particular method of doing it. There are at least 3 in the document.
So I actually wasn't done. I had a completely separate thought, which is, I wonder, and this is really going completely beyond this, but I'll make it really quick. If we need to, or if there's any ground to be made by revisiting the requirements for the idempotent properties of TCP, and because most modern applications don't actually use it, and just using the happy eyeballs approach to a whole lot of these problems, to doing TCP version negotiation just up front. This requires being able to potentially have 2 connections complete with the same transaction, which is a problem.
Yes.
For some applications, but how big a problem is it?
Are you done with your slides?
Is that my last one? Oh, the unknown option was just a way to be able to explicitly say, I don't understand that option. That's all I need to say about that. So I'm done.
Cool. I'll go take a closer read of your draft now. I want to thank Wes Eddy for telling me that you had come up with this, and I think there was a previous, I don't know if it was 1 or 2 IETF meetings ago, you weren't able to be there.
Last one.
When we had a TCPM meeting when we actually discussed, we spent quite a bit of time discussing this, and then there was a lot of hallway conversation afterwards. And I think what you've proposed here is the nicest in the sense that they had this gut reaction to it. It's very nice. It's clean architecturally, and it's the easiest to understand. I think but I think a lot of us, in trying to think about this, even if we thought of this one, quickly moved on because we really want to be able to negotiate an option in that first round trip time because we also want to get data because squeezing round trip times out of everything is a big goal these days.
Yes.
So I hope we can, I don't know if it works, but I just want to give a thumbs up. Thank you for thinking of this and writing it down.
Thank you.
I don't know if but I think the desire to squeeze out round trip times makes this sort of proposal problematic, and unfortunately all of the other proposals which try to do something about that are much harder to think about. And I think that's just the state we're in.
Yeah.
I think the chair said something at the last IETF meeting about how we're going, this is something we should take seriously and try to figure out something to do, but we don't need to decide quickly or something.
No.
Maybe you want to say that again. That was a very good thing you said at the last meeting.
So maybe I can, as in any case, we will not make an adoption call for this one, so that's pretty clear here. But we approved this presentation exactly for this reason, because we think it's an interesting idea.
Jana, I think Tim said what I was thinking, but in a much nicer way. And I think that this is very clean. It's extremely clean, but the RTT problem persists, and there is a serious issue with that. I think I want to reiterate one more point that was brought up earlier. I came to the mic earlier, but Yuchen said it. The SYNAC bits in the opposite direction, going from the client to the server, it'd be good to know how problematic that might be.
Right.
Getting through middle boxes.
I don't know that right now. And that would exist today with the simultaneous open, where each side sends a SYN, and then each side sends a SYNAC back. So
but like you said, in the common case, you expect that the NATs will drop the SYN coming in from the server to the client, and therefore you wouldn't see the SYNAC going back out.
Right. Yes. But anyway. I think we need to move on.
Yeah, we have to move on anyway. Just since I've been asked as chair about our position, so I basically mentioned this earlier, so that's the last slide in the chair slide deck. Currently, the chair's understanding is the non-SYN case seems to be the more low-hanging fruit, and we had a long discussion even about that one. And so that's why, for the moment, we don't see that we really have a valid solution to the SYN case right now. That doesn't prevent us from discussing it, but from a chair perspective, none of the proposals that we see here right so far are ready for adoption, for example. That's the one thing. And the second thing is also, this is really, as vendors have to step up here as well. So because some of these things will only fly if they get widely adopted, and we are not really there so far. We are still all brainstorming, which is good, but for the moment, the chair position is we will work on the non-SYN solution, and we will give time for the more advanced ones, but also keep in mind the last sentence here. Some of these proposals are probably beyond the minor TCP modifications, and that might mean that this is not a working group for doing them. But we will give 2 weekly time to discuss it because it's good stuff.
Could I suggest this is the working group where we discuss it, even if we can't adopt it here?
Yeah, as we will give room, as typically we ask for a long time slot, and we will give room, but we will not adapt at this stage. So, but since I'm running out of time a little bit, so I want to give room to Brian with the last presentation for today. Or are there any comments on this one here?
Yucheng Chen, just a quick comment on SAC being useful for the extended option space. I'm not sure about that, and I'd like to see there's any research or studies on that. Because TCP has been criticized, you can only support 4 SAC blocks or 3 SAC blocks at a time if you use timestamp option. But SAC option is really like you provide the newest halls, so you don't have to repeat the entire, you don't have to present the entire sort of holes in the receiver queue. So I have never found that the lack of SAC options being a critical problem on TCP. But other protocol has been criticizing TCP can only support 4 SAC option. So this is really neat. I just want to see how we justify that it's useful with the extended options for SAC.
Okay, as in any case, I've seen a list discussion on this, and that's also clearly, so this will have to go on anyway. So I'm still suggesting that we give the last 20 minutes to Brian for his presentation.
Good morning. I'm Brian Wise, for those of you that don't know me, and I'm here not to bring you a new option, but to discuss a update to an existing option. Okay. So a little bit of background on authentication for TCP. You might remember RFC 2385, which was published a long time ago. It was published on behalf of BGP implementations primarily. As a way of providing authentication of every segment that went between the two sides of the BGP session, including the SINs and the SYNAC. It's used particularly when you don't really trust the network between you and the guy on the other side, which is true often when you have 2 different ISPs, for example, that you're with a BGP session in between them. At some point, it became understood that MD5 wasn't a very good, wasn't a sufficient algorithm anymore, and algorithms tend to get weaker, or shall we say, the environment around them gets stronger, and so it's important. It seemed important to look for another set of algorithms, and that led to actually publishing 5925, which is TCP/AO, which had some additional security features and benefits as well as changing algorithms. So one of the things that TCP/AO did, which was really valuable, was added algorithm agility. And what algorithm agility is basically just the idea that when you specify a protocol, you leave some room to replace the algorithms in it or augment the algorithms in it when you need to. And that is because, as I was mentioning, over time, we find that the algorithms that we're currently using are no longer sufficient. Attackers have more CPU and they can bang away at things, or they develop additional cryptanalysis techniques. And this is just very normal, and of course this is what happened with 2385. So TCP/AO, when it was specified, is actually 2 documents. 5925 is the method of how you do TCP/AO, and 5926 defines the cryptographic algorithms. Next, please. 5926 currently has 2 algorithms for integrity protection: HMAC SHA and AES 128 CMAC, which is a way of using AES to produce an integrity tag. There's no encryption involved. And also because TCP/AO decided to start with a master key and generate a new session or traffic key for every TCP session, we need a key derivation function to compute the traffic keys, and so those are also defined in this. And these are all must algorithms because it was determined at the time that we should have 2 in case we don't trust one anymore. So now finally to our draft. We're proposing a 3rd one, and the first reason is why. Is there anything wrong with the 2 that are in 5926? The answer is no. But SHA-1 has been generally replaced with SHA-256 in the sense that it's the next version, if you will, of SHA. And it has more computation, has a larger integrity tag, so it is a stronger algorithm. And there are certain communities that won't use SHA-1 anymore. So what we believe is that those communities will use the TCP/AO if SHA-256 based algorithm and KDF are specified, and that's what this document's all about. So the two things, the first is the KDF. It's very simply, this is just like what 5926 does, except a different algorithm. SHA-256 is the algorithm, and the master key that is shared between the two sides is the key, and then the context is this TCP context. In this particular case, we end up with a 256-bit value, and that's fed into the MAC, which is on the next slide. So now we have a traffic key, which is a 256-bit value, and we have the message, which is again just as defined in the RFCs. And what we are doing with that is we're going through HMAC SHA-256, which gives us a 256-bit value, and then we're truncating it to 128 bits. I should point out that this is common with these algorithms to truncate them for when we're passing them in network messages. I should also point out that cutting it 256-bit value down to 128 is the smallest that has been is allowed by the HMAC RFC. Lower than that, and it's deemed insecure. So just as a sort of a preliminary for the next slide, 128 bits is as small as we can go. There was some discussion on the list over the past few months, and we appreciated that very much. We think we've resolved most of them, issues, but there's still some discussion. And we have a couple discussion points. The first is the size of the option, which we've talked a lot about already this morning in terms of needing extended options. But just to point out, the existing two integrity methods end up with a total of a 16-octet option. And because of the larger MAC, which is for the greater security, we have a 20-octet option. Now, there's 40 available, and Section 7.6 of 5925 is a nice discussion of what other options that you might expect in a SYN and non-SYN. In SYN, these three options, the stack permitted, timestamps, window scale, are expected for 15 octets, which would seem to give us a budget of 25. We're going to use up 20. There's 5 left. That seems to be okay. There's some note about padding. Sometimes it's consumed some more, but it would seem to be okay. Okay, next slide, please. In the non-SYNs, it's a little more interesting. According to Section 7.6, there's either SAC and timestamps or DSAC and timestamps. And it looks like we'd be okay with SAC and timestamps, but not DSAC and timestamps. Next slide, please. But that's not all. There was Brandon Williams pointed out that that didn't include MSS option, which is more common, and that's another 4 bytes. And maybe the packing can be disabled. That was also discussed. One thing, we did do a little bit of analysis. I said investigation is ongoing here, but we did a little bit. We looked at 3 BGP implementations on routers, just as a point of reference. And all of those 3 use different sets of options. However, if we add the 40 octets for this particular algorithm, the RR40 or under. So it's merely a data point. I understand that this is also important for host implementations, but it is primarily intended on router stacks. Yes?
I didn't understand what you said about DSAC. DSAC doesn't normally take any additional space.
Okay. I maybe didn't understand it either because I just took what was out of the RFC, 5925.
It redefined some corner cases in the original SAC RFC that were sort of unspecified. And so it doesn't actually affect the length of the option. SAC works with as few as a single SAC block. If you're not losing too many ACKs, it doesn't actually need 3. And so.
Okay, maybe what was put in there was the worst case.
Well, that's going to blow your budget because SAC can fill all of it.
Okay.
Darryl Kivinen, Insight Secure. Actually, if you go back to the slide where you have the option size, or actually more or less, actually, you were saying that half of what you can truncate the HMAC, it's what the secure limit. it's actually the limit, okay, after that it starts limiting the security of the output. It means that it's not 256 bits anymore, it's less than that. Which means that you can actually truncate it 96. You are not going to get 256 bits of security, you can think, about double the 96, which is most likely perfectly enough because we are not talking about long-term security of encrypted data or anything like that. We are talking about on-the-fly, authentication tag of the object we have there. So the only way to attack that is actually, crack that 96 bits on the fly, while the packets are going on. And so I think it actually would be completely safe to actually truncate it to 96 bits and say that yes, we are not even getting that much security that we could get with the SHA-256, but doing it this way allows us to put it in the smaller hash. The other question I have actually is the TCP authentication option. Can we actually have it so that when we see the option length, we could actually see how long the hash would be there? So could we actually make it variable length? I haven't checked out the TCP authentication option that much that I could say that, okay, if it's there anything behind it or anything, could we actually just see that, oh, it's 12 bytes, so we need the hash is 12 bytes. If it's 16 bytes, we can do that.
There's no negotiation involved, and there's no reference in the frame to tell you how large that's going to be. You do look at your local policy and you would say, how large is that?
No, but I mean,
how many bytes am I expecting here?
Yeah, but
and that's the best you can do. So without a policy sort of framework that says I'm expecting 96.
No, but I mean, the TCP option has length. So you know that TCP authentication option is going to be certain length. So when you receive it, you know that, okay, if it's 12 bytes long, I don't remember if there's anything else in it. Actually, there's a couple of bytes extra.
There's other options in there, though.
So if it's something plus 12, then you know that it's 12 bytes long hash, and if it's something other than plus 16, then you know it's 16, which would allow us to also. This is actually some of the things that it will allow us to use shorter one, for example, in the initial packet, and then a longer one in the rest of when you have more space in TCP options. Because I think the SYN packets, it will have the less of it. But on the other hand, SYN packets are the ones that actually, they don't have data that much. So actually, hacking that 96 bits of, authentication tag just to be able to send a SYN packet is something that you can just copy it multiple times. It's easier than that when to hack the key.
Those are interesting ideas. I think the security policy, the people that want to use HMAC 256 will want a lot more than 96 bits of security across the board, whether or not it's absolutely necessary. So I don't think we actually can probably cut it down to 96 bits even for some of the.
Hi, David Borman. Just a quick clarification on your previous slide. You were talking about the MSS option, and when you talked about non-SYN segments, you don't have to worry because the MSS is only applicable on SYN segments.
Thank you.
Andrew McGregor, to the point about BGP routers, the normal BGP speaker on a peering point is a generic host. You normally have the routers talk to that. So, yes, the set of expected options is probably different, but it's generated by a fairly generic stack rather than something deeply embedded.
Yeah, the three that we looked at weren't generic hosts, and they all had very widely different sets of options, which was surprising to me, to be honest, because usually BGP implementations are all pretty similar.
Yes, but the TCP, of course, is in the OS kernel underneath the BGP. So, but yes, I mean, you could expect any number of things here because they are going to be run on highly tuned kernels. So even if it's a Linux or a FreeBSD, you expect that the option set would be different from a normal host deployment of that same kernel.
But I don't want to downplay hosts too much. I mean, it is important. There's BGP daemons that run on hosts, and those are important. Okay. I think we were done with this, yeah. So that was the first consideration, first discussion point. The second one was we were recommending 256. This is not a must. because there's no reason to change the musts. There's nothing wrong with either of the algorithms in there. This is just an additional one for when user groups have a security policy that's higher. So we originally wrote this document as not as an update, but simply saying, here's yet another algorithm that could be used. And we got two comments from both Joe and Gregory, who's one of the original 5926 authors, saying, oh no, we actually should put them all together. This should update 5926. So we're happy to go either way, whatever. If this became a working group document, that either way is fine with us. Okay. And that's really all. Any additional comments, questions, or are welcome. This does need to have some security area reviews to ensure that what's done is as good as we think it is, and then it's up to we'll leave it up to the chairs to decide anything else. Go ahead.
I was just going to say, it looks like 6925 needs an errata about the DSAC sizes, because that language is actually old language.
I'm sorry, I couldn't hear the comment.
5925 has got a bug in it regarding its language about DSAC. I will be filing an errata.
Thank you. Okay, any other questions? Thank you.
Wait a second. So actually I have two questions. So the first one is, looking at those option numbers, wouldn't be that a natural fit for EDO? So wouldn't be an option to serve the user communities that you mentioned that need a long option, to implement TCPO in together with EDO? Because then outside the SYN you have the room.
Yeah, Michael, I was actually thinking the same thing, because you're probably not using the TSO, GRO, and other kinds of three-letter words that in these platforms, right? So all the problems or open questions we have there might not apply in this.
It might not be that simple, but at least it looks like yet another relevant use case for EDO.
I mean, TCP/AO itself, I don't think works at all with those, TSO and GRO kind of things. Because the signatures would break. So.
And then I have a second question. Can you confirm that there's running code on TCP/AO already? Because this was always be a little bit controversial, whether it's TCP/AO or maybe the predecessor variants of it.
I'm sorry, I didn't hear what you said.
Can you is there running code on TCP/AO? Because this has a long history, to the best of my knowledge, and I'm a little bit wondering whether, if we do this here in the working group, whether that would yield to more widespread deployment of TCP/AO, and that would obviously be an incentive to do something. But I'm wondering, is there already running code for TCP/AO? One of the reasons for asking this is the attendance status is proposed standard, and in Tcpm the bar for proposed standard is pretty high. Usually we expect running code. So that's I'm a little bit wondering, as you mentioned 3 platforms, but is there running code where you could test this?
Right, good questions. So TCP/AO has had a rather slow deployment, which is sometimes the case with how do I say it? Sort of difference between BGP vendors and the operators asking for things. So, however, it is now being deployed.
Okay.
There's code being written,
okay.
And that's where really this draft came along. We came to the understanding that certain user groups wouldn't use existing algorithms. So it would in fact increase the deployment of it. But it's a fair question to want to see evidence of the running code and some implementation experience.
Okay, thanks. So I will probably not do an adoption call right now, because there's still open questions here, but we didn't have a lot of TCPO presentations recently, so that's why I'm a little bit interested if we would do something in that space, if we would find, for example, reviewers for that work. To give me an understanding for this, how many here in the room have read that draft? And so I see one, only one. Who would be willing to review a document in that space? So that's not an abduction call. I'm just wondering who would be willing to review something in that space here. So I don't see anybody. So the issue that I see here right now is I think this is actually in scope of TCPM. TCPO is a TCPM product in some sense. So, but I think we have to figure out how we can, if this is adapted as proposed standard, we need, let's say, to have a team of reviewers that can look at this. As we will have a look at the sector stuff for sure. But I would really look forward to have some people here in the room that are willing to tell us, okay, this is good stuff, it works this way. As for example, regarding the option length things or these things. And we don't need many reviewers, but if I have 0 here, it's a little bit hard for me. So I'm really wondering if there's a way to get more people involved here. That might not have to be the usual TCPM contributors. So maybe we need people from the outside, but this is probably something that would help us here. I think it's in scope of our charter, but if we have 0 reviewers for proposed standard, it's pretty hard.
Yeah, it's reasonable to ask some of the more of the BGP vendors.
Yeah, it would be, my suggested next step would be that some of the BGP people, for example, we can have another discussion, for example, in the next meeting, and it would be good if some of those people were here in the room and would basically discuss with us and offer feedback or reviews, because we can, I think technically we can do this, we can sort out the details, but there's no reason not to do it. But we do need, for proposed standard, we do need people that review it, and that's, I think, the next step. So personally, I think we can do this, but we need people, and I would suggest to have an offline discussion about how do we get those people here in the room so that they talk to us and support it.
Thank you.
Okay, and that's the last step. If you haven't signed the blue sheets, then please do so. And other than that, thanks a lot for the long discussions. Sorry for running a little bit over time. This was not expected, but that's not unusual in TCPM. And let's have good discussions outside on the hallways, and see you again then in the next meeting. Thanks a lot.